is a convincing argument that shows why a statement is true. A two-column proof is an organized way to present your argument. Basically, we've sort of been doing it already because we would make a statement and then we would say given, or we would make a statement and we would say reflexive, something like that. So, this is kind of the procedure. You may not need it once we get going. But first thing you do is list the given information. So most of you probably have done that already, hopefully. But you have to write it over. You have to write whatever is given. Use the information from the diagram. I always mark up my diagram. I'll show you. Give a reason for every statement. Use given information that you have learned. Use a reason for every statement. Use given information such as definitions, properties, postulates, whatever we know, and theorems. You don't have to state theorem numbers. You just need to, say, definition of angle bisector. Good enough. What does an angle bisector do? What's it do? Cuts an angle exactly in half, right? Exactly. Okay. List statements in, I'm going to change color here. Does this help? Some people are squinting. List statements in order. If a statement relies on another statement, list it later than the statement it relies on. For example, if you're told that two lines are perpendicular, you would say two lines are perpendicular, they form right angles, and then you would say right angles are congruent because they're both 90 degrees. That's what I mean. Okay, something like that. We'll see. End the proof with the statement you are trying to prove. Okay, let's just try it. We're just gonna jump in. It's all reasoning, logical reasoning. That's all proofwriting is about. Logical reasoning, step by step. Pardon me?
Do we do this in your classes?
All right, let's go. So first of all, what they gave me here is A is the midpoint of KM and PQ. At this point, I'm going to mark up what I know on my drawing. So A is the midpoint of KM. What does that tell me then about this piece and this piece? If A is the midpoint, what do I know? I know this and this is congruent, correct? If it's the midpoint of this, I also know that that and that is congruent. This is all given to me. What other thing do I know about this picture from previous knowledge? What else do I know? Diana? That these angles are congruent because they are what kind of angles, Diana? Vertical. Vertical. Oh, okay. So I marked up everything I know. I'm going to cover up one of the triangles, and I'm going to say, which congruence postulate can I use? Side, angle, side. Do you see it? Yes, Angela.
Does it matter what order you put it in?
You mean when you write the proof? You mean when I write the proof?
Oh, never mind.
Okay. All right. I know that I have to prove this. So it might help me to write side, angle, side. I need to prove these things in my statements. So the first thing I know is that KA, I'm going to start with a pair of sides, is congruent to AM. How do I know that? Because A is the what? Yes. Okay, it's the definition of midpoint. Midpoint cuts a segment in half. Okay, the next thing I have here is I want to prove my angles. I'm going to prove my angles. So I can't just say angle A. I have to say angle KAP is congruent to angle MAQ. How do I know those angles are congruent? Which theorem are we using? What kind of angles are they? Vertical. They're vertical angles. Okay, so I did these two sides, I did my angles, now I have to do these two. So I'm just going to say side PA is congruent to side QA. How do I know this? What do I know? Midpoint, definition of midpoint. Did I do my side, angle, side? Have I proven every statement? So then the last thing I have to do is end the statement with what I'm trying to prove. So I need to say triangle KAP is congruent to triangle MAQ. I need to state that, and I need to state why I know that. Which postulate am I using? SAS, right? Because of the SAS postulate. That's it.
This sucks.
Really? It's not that hard, is it?
Yeah, it's not that hard. It's a lot of writing.
It's writing. Writing proofs. Okay, let's do another one. Oh, we have a few to go through. Don't worry. So, hopefully you wrote the givens, okay? Now, let's see what we know. We're going to mark up our diagram. Shh. We know that AT bisects PAM. So AT bisects this angle. That tells me that this angle and this angle are congruent. Yes? Okay? The other thing they told me is that angle P is congruent to angle M. So that means these two angles are congruent. What other thing do I know in that picture? Jess? Right on. I know that this is equal to itself, correct? Because of the reflexive property. That's all I can do on this picture. So I cover up one of the triangles, and I say, which property then am I going to use? Yes. Joshua.
Oh, angle is the side.
Everybody look up here. He's right. I'm going to use angle, angle, side. Why is it not ASA? Okay, order matters. Why is it not ASA? Because the congruent side is not between the angles. Right? It's order, angle, angle, side. Okay? So I'm going to use AAS. That's what I'm trying to prove here. I'm going to write that down. So then over here, I need to do angle, angle, side. Oh, look. I already was given one of my angles. I already wrote that down. This already proves one of my angles. So I got to talk about my other angle over there. So I'm going to say angle PAT is congruent to angle MAT. How do I know that these are congruent? What did they tell me about this right here? It bisects. So I would just say, I don't know, definition of angle bisector. Last thing I need to talk about is the congruent side, which was this. So I'm going to say AT is congruent to AT. How do you know that? Is that what you're going to say? Reflexive. Okay, I've proved my three things. The last thing I have to do is write what? Yeah, I have to write the closing statement. Triangle PAT is congruent to triangle MAT based on which postulate? AAS. Okay? Yes, Brendan.
Is there actually a constant that's A as well?
No, there is not. So if you get the naughty word, you can't use it.
Will it work though?
No, it doesn't. It doesn't work. Okay. All right, let's look at this one now. So hopefully you wrote your givens down. Let's start with this. Segment DA bisects angle CAB. What does that tell me? That tells me that this angle is congruent to that angle. So mark that down. The first given. And then it says, triangle CAB is isosceles with base CB. So this is the base. If that's the base, what does it tell me about these two sides? If it's an isosceles triangle, these are congruent, aren't they? If it's an isosceles triangle. So I'm going to mark that. One more thing I can get from an isosceles triangle. What else can I get from an isosceles triangle? Has to do with these. Yeah, the angles opposite the sides are congruent if it's an isosceles triangle. Isn't that cool how it's all coming together? Oh my gosh! This and this, these are congruent to each other. Yes. I'm sorry, what? It could be two. This one could be two. Let's look at this one first, and then we'll talk about the other one. So now I think I have enough. Cover up one triangle and say, what do I know here? Angle. Come on. Which postulate? Angle, side, angle. That's one postulate I could use. So I'm just going to use that one. But Brendan is right. There is another one. Does anybody else see it? There's lots of them we could use on this one. There's lots. Remember now, this is congruent to itself, isn't it? So we could do side, angle, side. We could do angle, angle, side. There's lots of them we could use, but we're just going to use ASA for now. Okay? So let's prove this. ASA. I'm going to let you do one on your own next time. So, let's prove the first angle. I'm going to say angle CAD is congruent to angle DAB. How did I decide that these were congruent? Because of the bisector. So definition of angle bisector. Okay. I'm just going to talk about this side here. This side and this side. Let's do those. Side AB is congruent to side CA. How do I know that? That's coming next. I'm talking about the sides. What do you know about an isosceles triangle? Two of the sides are congruent. That's all you got to say. Okay, because they told me it was isosceles, so I would just say definition of isosceles triangle. Isosceles, I can't spell that. Isosceles, that's spelled wrong. It's supposed to be an L. Okay, now, somebody said the last one. Angle C is congruent to angle B because of which theorem based on isosceles triangle? Which theorem is it? Base angle theorem, yes. Jane is completely checked out. Are you writing? Okay. So I proved my angle, my side, and my angle. The last thing I have to do is make my statement. So I'm going to say triangle ACD is congruent to triangle ABD based on the ASA postulate. And then I can do my statement. Triangle PAT is congruent to triangle MAT based on what postulate? Which postulate did we use? Side, side, side. That's really the only extra thing you had to write down. Hold on. Okay? All right, I'm not going to write this one all out, but I want us to decide together which postulate it would be. So, if PQ is parallel to SR, if I have parallel lines, I should start thinking right away, what about the angles? If I have parallel lines, Tristan? If I have parallel lines, I should start in my mind thinking, oh, I'm probably going to have to work with what kind of angles? You guys know?
Q.
No, what am I going to have to work? Alternate interior angles. If I have parallel lines, I'm probably going to have alternate interior angles. So if I extend this, you don't necessarily have to do it. There's my parallel lines. Here is my transversal. What do I know about these angles? They're alternate interior angles, and they're going to be congruent, aren't they? Oh, well then that means that these are also alternate interior angles. Parallel lines, you're going to have alternate interior angles. What's the last piece of information I can know from this drawing? What's the last thing I can know? It has to do with the side. Leah, what do you think? What's the last thing I can pick out of this picture? It's about a side. I know one of the sides is congruent. Which one? This one, right?
Oh, yeah.
How do you know that? Because of reflexive property. Okay, so ladies and gentlemen, what I want you to do now, we've marked it up, we cover up one triangle, and we say, which postulate are we using? Angle, side, angle. Angle, side, angle. Do you see it?
Yeah.
Okay, we're not going to write it all out because we don't have time. But we're going to be using alternate interior on this one. We're going to be using, let me show you mine. I did write it out, but it looks like this. If you were to write it out, it would look like that. Reflexive and alternate interior theorem. Okay, I know. All right, let's look at this last one I have here. We're going to mark this up. Let's see which postulate we would use. So, eyes up here. Stay with me. You guys have been great so far. Segment YO is perpendicular to segment BT. What do I know is formed with perpendicular lines? What is formed?
90-degree angle.
Oh, so these are 90-degree angles. Oh. Okay. These are 90-degree angles. I've done that one. OB, OB is congruent to OT, so I'm going to mark that up. I also know that this is congruent to itself. I know that. But can I do ASS? Can't do ASS. There's something else I know. Does anybody see it? Something else I know. Jess, what do you see? We don't know for sure. I don't know for sure it bisects it. I would think it would. But there's something else that we can definitely see from this picture. Joshua, what do you think?
Would it be SAS?
I'm looking for some other piece of congruence first. Marta. Ladies and gentlemen, it's a nice isosceles triangle upside down. Isn't it?
I don't know.
Yeah, so that tells me that this angle and that angle are congruent.
I see two scaling triangles.
So, all right, let's cover one of these up. What can I use? Which postulate can I use?
Side angle.
That's not one of them. That's ASS. Yes, the serial. Which one? Angle, side. Absolutely. Angle, side. Okay, so that's what you would use for that. If you're not seeing it, look, it's this angle, and that side. Angle, side. This is what it would look like. This is why I wanted you to write down all your givens. I told you it was long.